Hi everyone, welcome to Barcelona and our first ever Avalanche Summit. I'm here with Sergey Nazarov, the co-founder of Chainlink, and I'm thrilled to be chatting with Sergey today. I will talk about everything that's oracles and runtimes for blockchains. Now, Chainlink, for those of you who may not know what it is the industry standard Oracle network that connects Web3 applications to real-world data and to off-chain computation. It secures tens of billions of dollars and provides a critical infrastructure service for powering DeFi. So as well as other applications, other services like blockchain-based gaming, parametric insurance, and many, many other verticals. I'm thrilled to be here with Sergey, and thank you very much, Sergey, for joining us. Let's dive in.
Thank you for having me. Great to see you again, Eamon, and thrilled to be here with you at the conference. Thank you.
Great. So let's see. I think our friendship, goes a long ways, but the audience may not know how it started. So do you wanna tell the world about how we met and how the Chainlink Avalanche partnership got its initial start?
Yeah, sure, absolutely. So I think it's from the early days of IC3. I've always been a fan of your work and Ari's work, our chief scientist, who you know from IC3. And I think through those events and through being a part of that, I kind of came to know you. And I was always very impressed by your research and a lot of the thoughtfulness you had around building these systems, way back when, even over 10 years ago, even before a lot of this stuff existed. So I think we were just in a kind of circle of folks that were looking into this at an academic level. And I was very lucky to be in that group. And we kind of got to know each other that way. And when you started building Avalanche, I thought it was very impressive, and I knew it would have a lot of the right approaches based on your past research. So we got in touch and saw how we could work together, and I think that's gone extremely well. But I think the real origin is from the academic world and our time at IC3, which is a great organization that I'm happy to support, and you're very involved in. And I think it really did what it was supposed to do in bringing people together, even with this just as an example. So I'm thrilled that we met through it.
Absolutely, yeah, it really did. So we were at IC3, we were one of the first researchers to understand the importance of connecting blockchains to the external world. And you were one of the very first people in the entire space to realize how important that was going to be. So that's exactly right. That's how the initial friendship was forged. And I was always impressed by how much you sought academic research and the cutting edge of technology as powering the engine behind Chainlink. So, and in fact, from my perspective, once we got started, I think one of the very important things that we did was to partner with you guys. It's absolutely essential for any blockchain to have accurate data feeds, and these feeds are enablers for everything under the sky, especially DeFi. Decentralized finance needs information from the external world on what's happening, what the prices are, and what else is going on. And so having Chainlink oracles has meant that we could support a vast variety of DeFi applications. So from your perspective, though, I'm curious, what are the examples of applications and use cases that are unlocked when you couple Chainlink oracles with a high-performance, high-capacity chain like Avalanche?
Yeah, so I think that the key terms you said, there were high performance and high capacity. And the reality is that when you make systems more scalable, use cases tend to expand to new kind of productivity frontiers. And also you have entirely new use cases that become possible. So I think it's really in those two categories. What use cases kind of get reinvented and reach a new level of capabilities, and what new use cases become possible. I think right now DeFi is still leading the charge on innovative new capabilities for blockchains. It's still the main use case aside from NFTs or insurance or others. So I would say that high-speed financial applications are kind of the norm in the Web 2 world. And for the Web 3 world to really compete and to have parity with the Web 2 world on the level of various financial applications, you do need a high-speed chain or a high-speed set of chains or set of systems that interoperate to create scalability. And so the thing that I think Avalanche does is it provides that, and it seems to be providing that at higher and higher speeds with maintained uptime, which is another thing that you need to be at parity. So I think the first thing is reaching parity with web systems on speed and reliability guarantees while giving these unique properties of blockchains. So that's the first big thing. And then our role in that is providing high speed, highly reliable data from hundreds of different sources, which we pretty reliably do today, providing very high speed data from the original source of market data or data providers, and often a collection of both. So I would say high speed financial applications is first. After that, gaming has user experiences where people are not really very patient. So having a high-speed blockchain-based system that can cater to people's demand for fast gaming interactions, you don't really want to wait for a poker hand or to see what you won in a game or to see the result of some gaming outcome. People don't really love waiting for that for a long time. And so having the usability to give people a fast gaming experience, once again, is a minimum, right? Because I don't think that Web3 applications are really competing against other Web3 applications. I think they are, but I think really what we're competing against as an industry is Web2 applications. And that means that we need to arrive at parity for speed and reliability. And then we have all these additional properties of tamper-proofness and private key control and all these other properties. But something like Avalanche, I think, gets us closer and closer and possibly arriving at parity with web system speed. So, and for gaming, that's also very important. And then the final thing that I'm interested in is NFTs and something we call dynamic NFTs, so DNFTs. And these are NFTs that are actually connected to real world events. And these could be in the financial services world, or they can be in the art world, or they can be in the gaming world. But enabling more advanced NFTs with oracles is something that we're looking into very seriously, and I've seen a lot of progress on. So I would say those are the three main categories of things that I'm probably most excited about.
That's really fascinating. So I want to dive deeper into two of these areas. Can you describe a little bit more about how Chainlink and gaming play together? I think people are very familiar with price feeds and the use of Chainlink oracles in DeFi, but the critical use of oracles in gaming, they might not be as familiar with. So could you describe that use case a little bit more?
Sure, absolutely. So randomness is a very common requirement for many games because the fairness of the game is derived from the randomness, right? So you do derive certain guarantees by running a game on a blockchain, but similarly to DeFi, DeFi is composed of the data and the on-chain state. That's really what DeFi is. And both of those need to be performant and secure, be live, do a lot of things, and they both need to meet those conditions. For gaming, I think randomness is really the analog to data, because a lot of games need to randomly generate winners, poker hands, the distribution of things like you open a loot box or there's a dungeon that appears. There's a lot of random events. And just like in DeFi, if you'd have data that isn't reliable or can be gamed by adversaries, they can extract value from those financial products. And basically,
I was going to say, people might not realize that the first volume of Knuth, the quintessential Bible for every computer scientist, spends maybe at least half of it on random number generation. It's absolutely essential to computer scientists. It seems like a boring or simple thing to non-computer scientists, but it's actually a very difficult problem. And in the blockchain space, the generation of secure random numbers is actually very difficult. It's a gameable process. So, or rather, if you use a protocol that is gameable, then just like Sergey said, you can get into situations where your opponent can predict what's going to happen in the game and have an edge over you. So these are all scenarios that you can just write off if you have a good source of randomness that's off-chain, that's coming from a trustworthy source. But then I want to go into this third thing you mentioned, these dynamic NFTs. So at Avalanche, we were one of the first people to say to the world, look, NFTs are not just a bunch of pretty pictures. They're credentials. They can play a role in the real world, and they can do all sorts of exciting things. And I remember having these conversations maybe 4 or 5 years ago with various people, and we haven't seen that many applications of such NFTs yet. Can you give us a glimpse of what you have in mind and what these dynamic NFTs might be coupled to?
Sure. So some of these things are related to sports outcomes, and we've already attached the performance of different sports games and specific players back to their NFT. So it's really tying that's in the sports arena. But if you create NFTs that relate to ownership, really NFTs can reflect the current value of something because they can be updated. And that relates to maybe things related to real estate or various other assets that are uniquely represented through a non-fungible single asset. So it extends to gaming, often in the arena of sports. That's where we've seen it most, because sports outcomes are always happening. There's always sports games, how many shots somebody made, how many times they hit the ball into the goal, that type of thing. And then there are a lot of other applications for assets that get turned into NFTs, but they need to be updated with, for example, the current auction price, or they need to be updated with any other properties that make them more valuable, so that the NFT actually reflects those things. So the early version of NFTs kind of have a floating value that people ascribe to them, and dynamic NFTs will actually reflect the value out in the real world as it happens. And that actually creates a more accurate representation of the value of those NFTs by them being dynamic.
This is fascinating stuff. I can't wait to own some of these NFTs. I can't wait to actually earn some of them by betting, etc., or whatever else it is that you're going to be distributing these through. So it's an exciting world. So I want to change gears a little bit and start taking a bit more futuristic view and start looking into the future. As you might know, one of the key scaling technologies behind Avalanche is not only its super fast consensus protocol, but its new architecture based on subnets, where essentially what we do to the world is to say, look, we don't want to build a single monolithic chain to rule them all. You can build such a chain, but such a chain will be limited, and there will be some dominant applications that cause everybody else's fees to go sky high. That will saturate that chain and will crowd out everybody from your initial chain. So for that reason, from the get-go, Avalanche was always designed as a family of blockchains, or a factory of blockchains. So we call these chains subnets, and they give people the ability to run their own virtual machines with their own validator nodes, creating their own networks. So how do you see Chainlink playing a role in a world where dApps are deployed on such subnets?
Sure. So I think subnets is a really interesting and relevant concept, because it allows people to cater what they need from decentralized infrastructure to their application, which in a certain way makes a lot of sense, and probably where everything is going over the long term anyway, because applications in and of themselves, once they really reach scale, whether it's for gaming or whether it's for a financial product at scale, that one application will likely need its own chain, will likely need its own scalable, single focused thing. And that's what I think this caters to. I think what this means for Oracle networks is that they need to do one of two things. They either need to inject data or randomness or identity information or whatever category of input that subnet needs directly into the subnet. That's one way to do it. The other way to do it is to have a large shared resource in the form of a subnet with a lot of data on it that is then shared by other subnets. And both of these approaches, I think, have merit, because they also have trade-offs in terms of speed and in terms of what is worth putting into a shared resource versus what is only needed by a single subnet. So I think where this is going to expand to is that you'll have these subnets focused on a specific application. That application will scale, and the subnet will, based on the parameters set by the application creator and based on various other factors, hopefully scale with that application. And the subnet architecture has a good chance of doing that because of how it's focused on that application. And I think this is the flexibility that you folks have really tried to optimize for, which makes sense. And likewise, we optimize for a similar flexibility with Oracle networks, where we have over 800 Oracle networks now, and those Oracle networks are really focused on a specific service. So they're focused on generating a specific type of data, or a specific type of identity input or some kind of specific input. And so those can also be configured to meet the demands of a relevant subnet. And then there are certain Oracle networks that are shared by, at this point, hundreds of different applications. And in this case, if each DApp ends up having its own subnet to scale, then you would have hundreds of subnets using, probably one Oracle-focused subnet focused on generating lots of data to share. That, I think, is a later stage once there's enough need to share data across subnets. Initially, I think it'll take the form of specific oracles for specific subnets that need that data at scale. But I definitely think this is an interesting and viable strategy to scale in the sense that it's actually focused on an app-specific approach that can be then modified to meet the demands of that application, which are very varied. And so that is a similar approach to Oracle networks that can be tweaked to meet the demands of that application based on what they need from the Oracle network. So I think it's very complementary in that sense.
Exactly right. I think one of our first discussions was exactly about this. That is, the ideas or the observations driving an architecture based on subnets are very similar to the ideas that are driving the decentralized Oracle networks used in Chainlink. And the combination of the two give us this really, really heterogeneous, really flexible solution where you can have a subnet that has very fast Oracle feeds, and you can have other subnets where the Oracle feeds are slower because it's not necessary to have that data. So it gives us a lot of flexibility, and the combination, I think, is going to be explosive. I cannot wait for a richer subnet space, and this next year I think is going to be really promising. So I have a different question, again related to the future, but to understand the future we kind of have to look backwards and understand the past. So I'm curious how the role of oracles and decentralized Oracle networks has evolved since you founded Chainlink.
Sure. So I think that initially we focused on creating a consensus method that would get data into chains. And initially that data was mainly market and price data because DeFi needed market and price data to come to life. And before Oracle networks were basically put forward by Chainlink in a workable form, a lot of people were building their own Oracle systems that were continually failing and not allowing those DeFi products to secure any real sizable value. So if you look at the point in time at which DeFi exploded and the point in time at which Chainlink provided reliable Oracle networks, there's a very, very high correlation. Likewise, with the amount of data put on chain by Chainlink networks and the growth of various DeFi markets, very, very highly correlated. I would say beyond that, what we've realized is that the Oracle network consensus mechanism can generate consensus about a multitude of other topics. So there's really three main categories. One of them is data, one of them is computation, and one of them is cross-chain communications. Data is a category where we're very well known, and we provide a lot of market and price data, which powers the majority of DeFi in many different environments, and really I would say the majority of DeFi in key categories like lending and derivatives at this point. The expansion there is really around other types of data, things like proof of reserves for wrapped assets, identity data, a number of other important pieces of data. In the computation world, there's randomness. There's keepers for automating contracts, giving them the time, triggering them, doing various key automation tasks. And then there's also fair sequencing services, which can help eliminate minor extractable value. Those are three of the main categories in computation, but there's others. And then the final category that we're very excited about, we're actually working on it with some amazing folks like Dan Bonet, who heads the Stanford Applied Cryptography Group, and some other folks of his caliber, is CCIP, which is a cross-chain communications method, protocol that uses the Oracle networks and their consensus method to generate reliable communication between chains. And so actually, Oracle networks are much more expansive than data. They provide all the off-chain computation that blockchains and subnets wouldn't provide. And some of that might eventually move into blockchains, or it might not. That's hard to kind of understand based on how those systems evolve. But what we've really seen is the evolution of Oracle networks and their ability to create much more computation beyond data aggregation. It's moved on to automation, fair sequencing, randomness, and soon cross-chain communications, which I think is also very important. So I think there's just this much bigger expansion to what Oracle networks do beyond data. Data is really the place where a lot of this got polished and got to made work correctly.
Right. So interesting. And so on that, continuing that thread, then let's talk, this is my last question to you. Let's talk a little bit about the future of things to come, especially about Web3. How do you see, I think we're finally at the cusp where mainstream is beginning to understand the importance of Web3, what it can do, and then what it means for internet services at large. How do you see Web3 evolving? What do you think are going to be the big winning applications, and how do oracles fit into that world?
Sure. So I think that Web3 is a reliable form of Web2. I think that's what people don't fully, I think, yet grasp. I think they look at Web3 as a tokenization method for speculation, or something with games and NFTs and art that they don't fully grasp because it has a modern art component to it. I think that really Web3 is the reliable version of Web2. And the preconditions for that being attractive are that Web3 systems meet the speed, scalability, and privacy properties of Web2 systems. So we are at least at parity. And then you have to think about what are the additional properties of Web3 systems that Web2 systems will never have. And that is user control, transparency to manage counterparty risk, and basically global access and efficiency. Now, global access and efficiency right now allows people to get 8% on the US dollar within the DeFi ecosystem. 8% on the US dollar in an inflationary environment is very, very attractive. So I think the reality of our industry is that we are quickly approaching parity on all the other features to Web2. At the same time, the world is becoming scarier, and inflation is becoming more of a problem, and user-controlled applications are becoming more desirable because applications that users don't control can basically screw over their users in ways that are unexpected and painful. All of those dynamics create demand, and the speed at which those dynamics happen actually creates more and more demand. So if DeFi becomes one of the few places where you can protect your fiat holdings against inflation by having an 8% rate of return, I mean, that is just very, very hard to compete with. And so I think different user bases and different verticals will come to Web3 for different reasons. For one of those three main capabilities: user control, transparency, or global access and efficiency. But at the end of the day, once Web3 systems are at parity in terms of their speed, scalability, and privacy properties with Web2 systems, it's kind of like asking, if I could give you the same exact application, but with a guaranteed set of outcomes for the application and more control for you and more transparency for better risk management, would you like the better version of the application? It doesn't make sense to me why anybody would ever say, no, I'll take the old, more risky, less controllable, less predictable version of the application. And that just doesn't make sense, just as a rational economic actor basis. And so I really think that the future of Web3 is just becoming the way that Web2 applications have to function. Once we as an industry and you and I and our respective projects can help bring the industry to the point where it can provide that infrastructure. So that's I think the big body of work that we're involved in, and that the academic community is involved in, and that I think is extremely worthwhile. And then from there, it'll be very rapid, because once again, why would you ever choose a less reliable, less controllable, less transparent version of an application? You wouldn't. It just doesn't make sense why you would. So that is the future. I think the entire internet will be powered by Web3 because it's a superior version, and it's going to be easy to do that. It's not going to be so hard, and the problems on privacy, scalability, speed, connectivity to resources, all of that is going to be solved. And that's the body of work that I feel that we're involved in, that, I'm actually feel very lucky to work on.
Exactly right. So I'm fully on board with everything you said, and in particular, I think we emerged on the scene at a time when everybody was looking at the performance of blockchains from the perspective of a single metric: transactions per second, and that's a metric on capacity, and it's not a metric on latency. And to compete with Web 2, you have to have the lowest latency chain. And that is what I think Avalanche brought as a unique ability into this space. And our ability to actually execute transactions at sub-second latencies means that people can suddenly interact with Web3 at granularities that rival regular Web2 interactions. So that's a big enabler. And of course, in such a world, oracles are key, in particular when Web3 applications are involved. What I think is going on behind the scenes is we're redefining the business model behind web services. And they're no longer controlled by a single entity that sells you ads, that builds a dossier on you, that ends up selling your private information to third parties. The business models can be far richer, far more interesting. And when you have such a world that's fully decentralized, there is no single entity that is in control. It's a collaboratively built environment. Then the role of oracles, the connection from these services to the external world, becomes ever more important. So maybe final question before I wrap up. What can the world expect in the collaboration between Chainlink and Avalanche going forward?
Yeah, sure. So I think that the goal that we both have is to make the blockchain industry's use cases more robust and useful in more and more advanced ways. I think that goes to the point that you just made. So I think what we can expect is more and more scalable systems from you, more and more subnets, more and more high-speed applications that can arrive at parity with Web 2 systems and become almost indistinguishable except for these additional benefit properties. And from us, our goal is going to be to continually provide more and more data, more and more randomness, more and more off-chain computation that blockchains and subnets don't do, but enables them to do more advanced things in the financial services sector, in the gaming sector, in various categories of global trade, insurance. And so I think what's going to happen is there's going to be more and more blockchain speed, more and more subnets, more and more apps, and they're going to need more and more decentralized services. And that's really, to your point, what Oracle Networks do is they create these decentralized services, of which now we are approaching over 1,000, and we're going to have thousands at some point soon. So I think the next steps are really going to be enabling a data-rich environment and a services-rich environment for developers to build more advanced use cases. And that is going to, once again, hopefully lead to those more advanced use cases that'll go on to redefine our industry, not so much in the form of tokenization or ownership, even though that's a great start for our industry, just like email was a great start for the internet. I think that's just a start. And so while tokenization and ownership are a key part of this, just like communications over email was a key part of the internet, I think really what our goal should be as infrastructure creators is to enable developers and new use cases to come to life at the speeds, privacy, scalability, and basic overall quality that can reach parity with Web 2 and then surpass it based on the unique properties of decentralized applications. And those unique properties, I think, is what I'm really betting on, you're betting on, the whole industry is betting on, is that those properties which Web 2 can never copy, which Web 2 can never implement, is really the key defining property that people want and will want more and more. So as long as that ends up being true, I think building infrastructure and services to enable that is a critical part of the path to enabling those use cases and those capabilities to redefine our industry. So I think together we can help redefine our industry in this direction, which I'm very excited about.
Fascinating, and as am I, actually, about our ongoing collaboration. So thank you very much once again for sharing your insights with the Avalanche community. Always a pleasure to have you. Thanks once again.
My absolute pleasure. Thank you for having me.